Welcome back to Next Wave News, where we dive into the science and tech that will define tomorrow's frontier. Today we're turning our gaze toward our own moon, and uncovering something odd in its largest crater that's raising new questions about what lies beneath. When NASA astronauts planned future missions, they focused on big craters, landing near them for both scientific interest and safety. But in one of the largest lunar craters, astronomers spotted a strange anomaly. Under radar scans and shadow measurements, part of the crater floor appears to be unexpectedly low, as if the surface has sagged or collapsed. This isn't a subtle bump or wrinkle. It looks like a deep depression where geology shouldn't allow one. The crater's rim, the surrounding walls, and even the impact-related rock debris patterns all suggest that something unusual happened after the crater formed. So what could cause such a localized dip inside a giant crater? One idea is structural collapse. Over time, parts of the crater's floor might have given way, faulting inward under its own weight, or through subtle moonquakes or thermal contraction. Think of it like an old mine shaft that slowly caves in after decades of erosion. Another possibility? Volcanic or magmatic activity. The moon isn't dead. Beneath the surface lie molten pockets, residual heat, and stresses. If magma shifted or moved, it could cause portions of the surface above to bulge or sink, leaving a depression. Yet another theory is that the crater floor might have been weakened by impact melt, when heat from the original impact liquefied rocks, which later cooled and settled in uneven ways. Over eons, that melt could have collapsed inward in places. Regardless of which scenario is correct, this anomaly complicates how we think about the moon's surface. It tells us the moon is still dynamic, its crust responding to slow internal stresses, cooling, or hidden geology. For future lunar explorers, this matters. If a landing site is near such a collapsed zone, the surface might be less stable than expected. And for scientists, unraveling this oddity could teach us about the moon's interior, its thermal evolution, and how lunar geology has changed since the great impacts. So the next time you look up at a full moon, remember, even in the silent emptiness, geological stories are waiting to surprise us. If this mystery on the moon captivated you, don't forget to like this video, subscribe to Next Wave News, and hit that notification bell so you don't miss any upcoming space revelations. Thanks for watching, and stay curious.